This is a 5-minute introduction video for our DeepID-Net paper. This paper has two contributions. First, pre-training. The second is on deformation handling. The first part on pre-training. The mostly used paradigm for object detection is to first pre-train the deep model for image classification on ImageNet, and then fine-tune the deep model for object detection. However, we observe that the classification at the pre-training stage has a gap with our target task of detection. For example, an image on the left-hand side is considered as an image having person. On the other hand, a blue bounding box enclosing this image is not considered as a good bounding box, so it is a negative sample for object detection for detecting human. On the other hand, for detecting human, these images on the right-hand side are only considered as the positive samples. If we use the whole image, that is the image containing two persons, as the class label for containing person, then the convolutional neural network learned cannot distinguish a bounding box that encloses the person tightly or loosely. And for the person, as we can see on the left-hand side, its image features are not so good. On the other hand, if we treat the image containing tightly enclosing person as the positive sample, then the learned convolutional neural networks can represent the visual features of the human in a much better way, as we show on the right-hand side. Based on this observation, we propose to replace the image classification for pre-training by using object detection, using object level annotation on ImageNet for pre-training the model. Experimental results show that using object level annotation by treating it as object detection can significantly improve the accuracy by more than 4%. The second contribution is the deformation pooling layer. This new layer is proposed for handling the occlusion. So this layer can be placed in any layer for the convolutional neural networks. Here we will illustrate how we can use an input image, and actually the input can be any input features. So for an input feature, we can use convolutional layers that correspond to filters. And here in this example, we used light bulb to consider it as the filter. So when we have a filter, we will convolve this filter with the input image in order to obtain the convolutional result, which is a response map like this. So as you can see, there are three high responses corresponding to the three light bulbs in the traffic light. On the other hand, there are also other high responses in the close-by regions, which is not desirable. If we use these regions for learning the visual cue of the light bulb, it will be noisy, so it will cause the degradation of the learned feature. In order to handle this problem, we can assume that this visual feature has its deformation properties. We propose to add another parameter to learn the deformation property, and the way we learn it is to use some deformation probability or penalty terms. So in this probability term, it will tell us that the light bulb has higher probability of moving horizontally, but less probability of moving vertically. So after this deformation property is added with the visual responses, then we will have the added response maps. So we can see that it is much clearer than before for the high response areas corresponding to the light bulbs for its corresponding correct locations. So after we consider both deformation property and visual cue together, we have the map as we show here, and then we get the maximum response for each local region and treat them as the final visual cue visual response for the filter of the light bulb here. And then we get the output. Of course, here we use an example of image and light bulb as the example. In the convolutional neural network, the input can be any layers feature maps. Experimental results on the ImageNet object detection dataset shows that the deformation pooling layer can improve the accuracy by about 2.5%. An important follow-up work for handling deformation is the deformable convolution network.